All right. So this is actually you probably have learned before when we talk about two lines, and how do we know two lines are parallel? Well, the definition for that is that if you got two lines and you you you're going to extend that forever on both sides, and if they never touch, they never intersect, and this kind of uh, lines are called parallel lines. And what we're going to learn today is learning about the properties of parallel lines and also how do we know two lines are parallel. So to do that, we first of all have to do to define our terms. Otherwise, we'll get confused. Now, there is a very important line is called transversal. Transversal. Now, transversal line is a line across those two lines. So not necessarily those two lines, let's say this is A, this is a B, and this line is C. So line A and B are not necessarily parallel. So it could be any two lines. But if you have a third line which crosses those two lines, and this line is called transversal. So we give it a special name, transversal. And sometimes we could have, for example, now this line cross three, that's still called transversal. And if you do some line like this, that's even, well, we know that this line will be the transversal of these two lines. And this line will be transversal of these two lines. So you could have different kinds transversals as long as the line cross two or at least two lines and that line transversal. Good? Yeah, if you're good, just give me a thumbs up. Okay. Now, given that if you have a transversal and you notice that there are actually 8 angles that they can make. So if we call them, this is our 1, this is our 2, this is a 3, this is a 4. So 1, 2, 3, 4, then 5, 6, 7, 8. Now you can see that they actually come in pairs. So the first category we're going to put them under is interior angles. Now, interior angles are all the angles between the two lines. So you can see in this case, angle 3, angle 4, angle 5, and angle 8. They are interior angles. So 3, 4, 5, and 8. Then we got 4 interior angles, and we also got 4 exterior angles. And of course, we have exterior angles. We got 1, 2, 6, and 7. So 1, 2, 6, and 7. So that's called exterior angles. Good? Grayson? Good. So that's our first classification. We separate them into 2 types. One are inside the 2 lines. We call them interior angles. We got 4. Then we got 4 outside. We call them exterior angles. And then we are going to looking at the interior angles and see the pairs. So 3 and 5 we call them angle 3 and 5. We call them consecutive interior angles because they are interior angles, but they are also kind of like on the same side of the transversal, so kind of like one after another. So we call them consecutive interior angles. So 3 and 5 are consecutive interior angles, and also 4 and 8. 4 and 8 are also consecutive interior angles. Okay, and we also have, we can look them at cross. So 4 and 5, they are interior angles, but the cross, the transversal, is on either side of the transversal. We call them alternate interior angles. Okay, and of course 3 and 8 also alternate interior angles. We got 3 and 8 alternate interior angles. Yeah, we're good here so far. Okay, and we go back. I'm right down here. 3, 4, 5, 8 interior angles. 1, 2, 6, 7 exterior angles. Okay, so we got interior and now we just, for the interior angles, they are either consecutive, which means they're on the same side of the transversal, either on the right or on the left, or they are that's consecutive, or they are alternate because they are on either side of the transversal. Okay, and we're going to say something called corresponding angles. Okay, corresponding angles, for example, this angle, I'm going to use a different color. Okay, this angle and this angle are called corresponding angles. One is in, one is out. So angle 2 and angle 5 are corresponding angles. So one is in, one is out. And of course, 3 and 6 are also corresponding. So 3 and 6 are corresponding. So one is in, one is out. And similarly, 1 and 8 are corresponding. And 4 and 7 are corresponding. 4 and 7 corresponding. Good? Okay, very good. So we did consecutive interior angles, alternate interior angles. Then we look at one in, one out. We call them corresponding angles. And lastly, we're talking about exterior angles. They also can have consecutive and alternate. So if we look at the consecutive exterior, consecutive exterior is this angle and this. Both are outside exterior, so one, and on the same side of the transversal. So 2 and 6 are consecutive exterior angles. And So I'm going to give some room here. And also 1 and 7. 1 and 7 are consecutive exterior because they are exterior angles. Okay. And then they also have alternate. So 2, angle 2, this angle and this angle alternate on different side. Alternate means on different side of the transversal. And 7 are alternate exterior. And of course 1 and 6 are alternate. Good? Yep. All right. So now we're going to looking at some properties of those angles. So you got 2 lines here. You got transversal. This time I'm using a letter. This is A, this is a B, and this is a C, this is a D, A, B, C, D, E, F, G, H. Okay? Now, the one property is that if corresponding angles are equal, that means if we got 2 lines here. This is our A, this is our B, and this is our C. So if angle A is congruent to this angle, and this angle as corresponding. If angle A is congruent to angle C, that means corresponding angles are congruent, then A will be parallel to B. So that's the line here we got using this for the parallel sign. Now, sometimes we're actually using over 2 letters for the line. So let's say if we use 2 letters, we can call this AC and this BD. So we can write as CA and DB. Yeah. Normally we use 2 letters because 2 points define a line. So that means if the corresponding angles are equal, then the A and B are parallel. AC and DF are parallel. Good? Yeah, are we good here so far? Okay. Well, the reason for that is if these 2 are congruent, now we can see, we know A plus B is 180. And we also know that A is equal to C. So therefore, C plus B is 180. Well, if these 2 angles add together 180, these 2 lines are parallel. Okay, this actually comes from the basic rule for parallel to define parallel is that if these 2 add together is 180, then those 2 lines have to be parallel. Good? Now, the reason for that is if those 2 lines are not 180, what we have, then we actually had a triangle here, and they are going to meet somewhere if you're going forward. That means if they are not 180. But if they are bigger than 180, then they're going to meet on the other side. So therefore, when they are 180, B and C are 180, then it's parallel. So therefore, that's our basic. Everything is based on that. Is if angle B plus angle C is equal to 180, then those two lines are parallel. So basically, everything we talk about here is based on this very simple property, simple rule. Okay, that's the first one. And second one is if alternate angles are equal and alternate angle are equal, so that means if angle G is alternate, if angle G is equal to angle C, then CA is parallel to DB. Well, we can see why is that. Remember, we just need to have to go back to here. If A plus C, if B plus C is 180, then those two lines are parallel. So if G is equal to C, which is C is here, these two equal. Well, we can see that angle G plus angle B is 180, right? Because they are on the same line. So if angle G is equal to angle C, then angle C plus angle B is 180. So that back to here. That's what we're starting with. So that's the what we got here. Okay, so 1, 2, 1 is talking about corresponding angles if they are congruent, the two lines are parallel. And now we talk about if in alternate interior angles is congruent, and then they are parallel. Good? Okay. So we have those two basically saying, how do we know two lines are parallel? And we're going to have, we call the inverse theorem is going, we're going to say what happens if they are parallel. So we got if CA is parallel to DB, then the corresponding angles are equal. That means angle A is congruent to angle C, or angle H is congruent to angle F. So those two there. And okay, then if CA is parallel DB, then the alternate interior angles. So that means G is congruent to C and B is congruent to F. Good? Yeah. Grayson, we're good on this? Very good. And now, if CA is parallel DB, then we know that the consecutive interior and not that. If two lines are parallel, if okay. All right, so that's what we have. So if two lines are parallel, then we know A is congruent to C, that's consecutive, and corresponding. Then if CA is parallel to DB, then alternate interior angles are congruent. We have that. And if CA is parallel to DB, then we know B plus C will be 180. Good? Yeah. Are we good here? All right. Okay, I'll send the homework out. Just work on that, okay? Yeah. I'll see you next time, okay? Bye.